programme, we'll be looking at some servicing and repair operations of the basic hydropneumatic system as fitted to Xantia models. Unlike the previous video, which looked at the principles of operation, this programme is of a more practical nature. However, if you haven't seen the previous video, we ask that you watch it before viewing this tape. Once again, there is an accompanying workbook, which, having answered all the questions, should be returned to CITROEN for marking. We've split this programme into 5 sections. The first of which deals with some of the underpinning knowledge that is needed before working upon the system. In the next section, we'll see how to change the fluid, make the system safe, and carry out some pressure testing of the source and reserve of pressure. Section 3 covers the setting of the suspension's height correctors and the testing and recharging of spheres. In Section 4, we'll see how to bleed the brakes. Before moving on to the last section, Section 5, in which a steering rack pinion control valve is overhauled. CITROEN provide numerous sources of information for you, such as the workshop manual, info rapid binder, the technician's handbook and the owner's manual, so please refer to them at all times. Before jacking up the vehicle, always set the suspension to the high position. And for your own safety, never get under the car unless it's supported by axle stands. Although towing eyes are provided, it's essential to recover a broken-down vehicle on a flatbed recovery truck, as without the engine running, the braking system will gradually become exhausted. Total LHM Plus is a mineral fluid, and thus it's important that it is not mixed with synthetic fluids. If it is, all the seals in the system will eventually perish, and the subsequent repair costs will be high. Being a mineral fluid, LHM attacks natural rubber, and so all hoses and seals are made of a special material. There is usually a mark, such as a green stripe, to identify that they are LHM compatible. And whenever a pipe seal is disturbed, it must always be replaced with a new one, having first coated it with LHM for lubrication. By the way, cleanliness is of great importance, as some of the hydraulic parts are specially machined to extremely small tolerances. And remember, when working on the hydraulic system, your own personal safety and that of your colleagues is paramount. Therefore, always follow the repair information and wear protective gloves and goggles when advised. That's dealt with some of the general points, so let's now move on and look at some of the operations that can be carried out upon the source and reserve of pressure. The hydraulic fluid level in the reservoir is checked through a sight glass. This is carried out with the engine running and the suspension in the high position. The level is correct when the orange disc is between the minimum and the maximum reference marks. One component you need to be aware of is the 12mm bleed screw on the pressure regulator. Although for certain procedures it will require slackening, never fully remove it, as beneath it there is a sealing ball that can easily fall out and become lost. And when replacing a hydraulic component or changing the LHM, the system must always be fully depressurized. This is achieved by putting the suspension into its low position, running the engine for at least 60 seconds, and letting the car sink. This returns most of the LHM to the reservoir. Next, switch off the ignition and slacken the 12mm nut on the pressure regulator by 1 turn, thus making the system safe. Incidentally, the whistling noise is made by the remaining fluid returning from the accumulator to the reservoir. The reservoir can then be carefully removed and emptied. To prevent dirt entering the system, use the special tool to temporarily hold the filter assembly. Cleaning components, such as the filters, is best carried out using white spirit as it's a mineral fluid, and then blowing through with compressed air. Please note that most workshop cleaning fluids contain synthetic solvents, so please don't use them and always follow the strict safety procedures, particularly when working with compressed air. If the LHM has been contaminated for any reason, then the system will need to be cleaned through using the flushing fluid called hydro-rinçage, or hydro-clean as it's more usually known. Follow the instructions in the repair information, but on no account run the car for more than 3,000 miles filled with hydro-clean. The customer must be advised of this and an appointment made to refill the system with LHM. On refilling the system, it will need bleeding. To do this, top up the fluid level to the maximum mark and then start the engine. The bleed screw should then be opened for 30 seconds and then closed. Repeat this at least 3 times, finally leaving it tightened. Next, set the suspension to high and wait for the car to rise fully. The fluid level is then checked again, topping it up as necessary with fresh LHM from a sealed container. Diagnosis of the source and reserve system employs several tests, including pressure testing the regulator and the accumulator, and checking the operation of the safety valve. Pressure testing of the source and reserve system is carried out using the pressure gauge kit and paying reference to the workshop manual. It's best to start by checking the pressure regulator, followed by the main accumulator and safety valve. Don't forget to depressurize the system, and then uncouple the outlet pipe from the regulator. Using a suitable pipe, connect the 250 bar pressure gauge to the regulator. Tighten the bleed screw and start the engine. The pressure in the system should increase until the gauge shows 170, plus or minus 5 bars. This is the normal cutout pressure. Once cutout has occurred, slacken the screw slightly. If the regulator is working correctly, the pressure will drop to 145, plus or minus 5 bars, at which point the pump should cut in and the pressure will rise again. The cut-in and cut-out pressures can be adjusted using shims, but this rarely needs to be carried out. To check the gas pressure of the main accumulator, the pump needs to have cut in, and so it's best carried out after completing the previous test. A frequent clicking noise from the engine bay, which proves to be the sound of the pressure regulator cutting in and out, is a symptom that the accumulator pressure is possibly too low. With the engine idling, slightly loosen the bleed screw to create a slow and consistent drop in pressure. As the pressure falls to somewhere between 100 bar and 80 bar, the stop light should light on the instrument panel. This confirms that the safety valve is moving and is operating its switch. As the needle continues to fall slowly, it will reach a point at which it falls quickly. This occurs when the accumulator has expelled all of its LHM and it can no longer accommodate the small leak we've introduced by opening the bleed screw. The point at which the needle falls quickly indicates the gas pressure within the accumulator sphere. The pressure should be 62 bar, with a tolerance of between plus 5 bars and minus 32 bars. If the pressure is outside this tolerance, recharge it or replace the accumulator sphere. To check the pressure regulator for leaks, connect the gauge directly to the regulator. Tighten the bleed screw and start the engine. When cutout pressure has been reached and the gauge has settled, in this case at 160 bar, switch off the engine. Over the next 3 minutes, note the drop in pressure. If it falls more than 20 bars in this time, then the regulator is defective and will need to be replaced. Incidentally, before removing the gauge, don't forget to depressurize the system, and on refitting the outlet pipe, always use a new seal. Adjusting the ride height, for example after replacing a height corrector, is relatively straightforward, providing you follow the information in the workshop manual. Essentially, this is how it's carried out on a Xantia. Before the ride height can be accurately measured, any stress in the front suspension must be removed. Ensure that the suspension is set to the normal driving position. Leave the engine idling and check that the handbrake is fully released. Next, check that the tyre pressures are correct. Remove any wheel trims and carefully fit the special tool. We'll check the front ride height first, referring to the repair information for the correct specification for L1. Start by measuring the distance between the centre of the wheel and the ramp. This measurement, known as R1, forms part of the ride height calculation. Then, before any further measurements are taken, push the car up. And then let go. Allow time for the vehicle to drop, then rise and settle. Your next measurement, referred to as H1 in the manual, can now be made. It is measured between the underside of the subframe and the ramp, and should be carefully noted down. Following this, pull the vehicle down let go, and once again allow time for the car to settle. Remeasure the height, and using your previous reading, calculate the average value of the two as your measured height, H1. Then, using the formula in the repair information, subtract the theoretical value, shown in the manual as L1, from R1, which gives you the actual value to be used as H1. Now compare your calculated H1 value with the measured H1 reading. If they are equal or within tolerance, the height is correct. If not, the height corrector will need to be adjusted accordingly. If the measured H1 is too high, the vehicle must be lowered, and vice versa. To adjust the height corrector, loosen the anti-roll bar clamp, which controls the automatic height adjustment, and the clamp of the manual linkage. Using the key, move the lever to set the height to the calculated H1 value. Note that there will be a small delay before any movement occurs, so don't force the lever. Once the height is correct, insert the setting pin. Then tighten the clamp on the anti-roll bar to the correct torque and remove the pin. Next, place the front height corrector setting tool between the spring ends in order to centralize the linkage. At this stage, the clamp bolt of the manual linkage can be tightened. It's a similar procedure at the rear. However, the measurement is taken from the body adjacent to the subframe mounting. And there is a different tool for setting the manual linkage. The calculation is also a little different, but it's explained in the manual. Having made the adjustments, remember to resettle the suspension by simply driving the car off the ramp and then back on again. Then recheck the vehicle heights and readjust if necessary. Recharging a sphere is possible provided that the gas pressure has not fallen to below 15 bar. If the pressure is below 15 bar, then a replacement sphere must be fitted as the diaphragm will have been damaged due to its contact with the internal fixing. The gas pressure falls over a period of time because the nitrogen seeps past the synthetic rubber diaphragm in much the same way as air slowly escapes from an inflated balloon. As the gas escapes, the ride becomes stiffer, and the customer may complain of this. To check the gas pressure, depressurize the system and remove the sphere. The sphere is then screwed onto the test rig, making sure it's fitted with the 100 bar pressure gauge. Turn off the tap and operate the pump. The pressure will rise and then settle at the sphere's gas pressure. Incidentally, the sphere's original pressure is stamped on the sphere. If the pressure is OK, then open the tap to release the hydraulic pressure and remove the sphere. However, if the pressure is low, then the sphere will need to be recharged using the gas bottle set, and not forgetting to wear the appropriate safety equipment. Firstly, clean the area around the sphere's charging plug, and then remove it by holding it firmly in the vise and slowly unscrewing the sphere. The seal will burst and the gas pressure will escape, allowing the sphere to be removed and the plug to be thrown away. Screw the sphere onto the trolley's mounting and then prepare the charge adapter as follows. Disassemble the adapter and ensure that this spindle is completely unscrewed. Fit a new replacement plug and new seal onto the opposite end, but don't fully tighten them together. Refit the assembly to the charge adapter. You can now position the charge adapter onto the sphere and screw in the new plug using the holder. Tighten the holder, but only slightly, using the sliding wrench. Open the nitrogen bottle's main valve and check that there is sufficient gas pressure in the bottle. Now, using the adjusting knob, set the gauge to the desired sphere pressure by opening the valve. Note, open means turning it clockwise. Add a further 3 bars of pressure to compensate for any losses that will occur during the procedure, and then wait for 1 minute for the sphere to inflate. It takes this long for the gas to pass by the plug's threads. The gas bottle is then isolated by turning the adjusting knob anti-clockwise, making sure it's fully closed. Now, using the vent valve, drop the pressure to the nominal sphere pressure. Next, screw the spindle into its assembly, which in turn screws the plug into the sphere. It may be necessary to prevent the holder from turning by using a wrench. Release the pressure in the hose by briefly opening the vent valve. Using the sliding wrench, unscrew the holder a couple of turns, making sure that the plug is not being withdrawn from the sphere. Then remove the charge adapter by unscrewing the spindle. Complete the operation by tightening the plug and test for leaks using a suitable product. And finally, recheck the sphere's pressure before fitting the plug's green protective cap. Fit a new seal and then screw the sphere into position, tightening it by hand. Oh, and of course make sure that the nitrogen bottle is turned off and that the equipment is stored away safely. After carrying out any repairs to the suspension system, it will need to be bled. To do this, simply set the suspension to high and then to the low position, repeating the sequence several times. When bleeding the brakes, it's important to remember that the system is power braking, and as such the pedal doesn't need pumping like conventional systems. It only needs to be depressed slightly for the fluid to flow. Start by moving the height control lever several times between the high and low positions to bleed the suspension system, and then leave the vehicle in the high position, as this ensures fluid is available for the rear brake circuit. Raise and support the car so that the wheels can be removed. Start the engine, and with someone lightly pressing the brake pedal, open the bleed screws and bleed the calipers in the order shown in the repair manual. Allow the fluid to escape until it is free of air bubbles and then close the bleed screw. Refit the wheels, lower the car to the ground and tighten the wheels to the correct torque. Finally, before road testing, top up the fluid in the reservoir. A typical symptom of a faulty pinion control valve is that the steering is heavy in one direction. If this is the case, or if it's leaking oil, then the valve may be overhauled, provided that the seal surfaces are not damaged. With the pinion assembly removed from the rack, prise off the dust cap with a screwdriver. And then, with a soft mallet, tap the splined end of the valve to separate it from the housing. Remove the circlip and both lip seals from the housing, along with the 3 square section seals from the rotor. And carefully clean the components. Fit the new lip seal and the circlip, then lightly lubricate the seal with grease. Having lubricated the remaining lip seal, it too can be fitted to the rotor. Next, the square Teflon seals can be fitted, remembering to lubricate everything with LHM. Their fitting position varies depending upon whether the car is left or right-hand drive, so refer to the manual. Once again, all the seals and tools must be lubricated before assembly. Using the cone, fit one of the seals to the assembly tool. This stretches it slightly, allowing it to be placed in the correct groove on the shaft. Always start, though, by fitting the seal nearest to the bearing. Then, using this tool, with a careful twisting action, shrink the seal, ensuring it remains within its groove. Carry on and fit the next two seals in the same manner. Having lubricated the seals and the housing, the valve can now be reassembled. To protect the lip seal, place the special tool over the splines and offer up the valve until the large seal contacts the housing. With the special tools located, place the assembly in the hydraulic press. Then, taking care not to damage the seal, press the seal and bearing into the housing. Having filled above the lip seal with G6 mineral grease, fit the new dust cap. The pinion assembly can then be refitted to the rack. To bleed the steering system after reassembly, simply turn the steering wheel slowly from lock to lock a couple of times. Well, that completes our programme on the practical aspects of the basic hydropneumatic system, as fitted to the Citroën Xantia. We hope it has been both informative and useful. Our customers choose to drive a Citroën for many different reasons. Your ability to maintain their vehicles to the highest possible standards will reassure them that they have chosen wisely and will uphold the integrity of the Citroën marque. Please now answer the questions in the workbook.